Session 2013, number 2. The aim of this exercise is determined by two different methods, the value of the capacitance C of a capacitor. And for this aim, we have this set up where we have R1 equal to R2 equal to 10 kilo ohm, and we have E equal to 10 volt. Charging the capacitor. So we'll do the position now, the switch is at position 1. Theoretical study, applying the law of addition of voltages and taking the positive direction in the circuit, show that the differential equation is of this form, as the differential equation in terms of UC. So we'll start with the law of addition of voltages. We have U of the generator equals to UC plus UR1, which means that E is equal to UC plus R1 times I. We know that I equal to dQ over dt, which means D CUC over dt. This means C duc over dt. So by substitution, E equal UC plus R1 C duc by dt, then it's verified. The solution of this equation is of the form UC equal A1 minus E to the power T over tau 1. A and tau 1 are two constants, show that A equals to E and tau 1 equal to RC. But this is solution, this means verify the differential equation. The differential equation كانت طلعت معنا of the form duc by dt plus إذا ما نقسم على RC plus UC over RC R1 equals to E over R1C. So by doing the derivative duc over dt here, we'll get, so this is UC, هنعملها expandable A minus T over tau 1, and then we'll do the derivative. So the derivative of A is 0 minus A minus 1 over tau 1 E minus T over tau 1. And then now we substitute, so duc by dt here A over tau 1 E minus T over tau 1 plus محل الUC رح نحط كل هيدي. So هيطلع لنا A over R1C minus A over R1C E minus T over tau 1. And then we bring this one here, so minus E over equal to 0. Now, the questions to verify A and tau 1. So اللي فيهم exponential رح ناخدهم as common factor. This means we have A E minus T over tau 1. بيبقى في عنا bracket بتاني mainly 1 over R1C. And هو the part اللي ما فيهم exponential كمان as common factor. So A minus E equal to 0, which means that this part is equals to 0. يعني tau 1 equal R1 times C. And from the second part, A minus E equal to 0, يعني A equals to E, and this is verified. Show that at the end of the charging, we have UC is equals to E. So part C, at the end of the charging, يعني T tends to infinity, T equal infinity, which means I have UC equals, so by substitution, E minus T over tau 1. I have T equal infinity, so E to the power minus infinity is 0, which means that UC equals to E, and this is verified. Show that the expression UAB equal UR1 is of this form. Now, نطلع الexpression لل UR, so this is UR1 equal. We can do law of addition, or we can do R times I. But بما إنه we don't have I, so what we can do is UR1 equals to E minus UC. So E minus, and UC here E minus T over tau 1, which will be equals to, so this is UC هيدي كلها, E minus E2, so يبقى لنا E minus T over tau 1. This is UR1. Now part E, establish the expression of the logarithm in order to find len UR1. So equals to len E minus T over tau 1, which is of the form len A times B and len A plus len B. So len E plus len exponential, and this will give us, so len E minus T over tau 1. This is len UR1. Now, graphical study, the variation of len UR1 as a function of time is represented in figure 2. Justify the shape of the obtained graph. It agrees with the expression of len UR. هلا إذا نطلع على هذه expression, so part 2a, if we look at this expression, it is of the form y, so this is y here, هيها, equals to a, so هيدي, it's of the form, this is a, so it's a t plus a constant plus b. So it's of the form y equal at plus b. Yani yes, it's true, it's a line, implies it's a line. It is a line and not passing through origin. So it's true, but this is not enough. But it's a line that's decreasing. So if I look at the slope, I have a equal minus 1 over tau 1, which is less than 0, implies it's a decreasing line. So هيك بنكون بيهنيها. Now deduce using the graph the value of c. In order to find the value of c, we now said that the slope here minus 1 over tau 1. So part B, I find the slope a equal, so it's y final minus y initial, so which will be equals here. بنطلع values, so equals to y final, it's 0, y initial is 2.3 over t final, so it's 23, but 23 milliseconds. So 23 times 10 to the minus 3 and minus 0. So we'll get here as answer. So بيطلع عنا. This means here it's equal to 100 minus 100. This is the slope. But the question is find c. So بيجي بقول له هيدي slope is equal to minus 1 over tau 1. يعني equal minus 1 over r1 times c. Which means that I can find c, minus and minus بيروحوا. This means that c equals to, so we have to find c, and we have the nominal value of r1. So we'll get at the end c equal 1 over, this is 10 to the power 4, and we have here 100. So it's 1, so it's equals to 10 to the power minus 6 farad. Then this will be the capacitance. We continue. Now we're in the part of discharging. The capacitor being fully charged, we turn the switch K to position 2, taken as new origin of time. During the discharging, the current circulates from B to A in the resistor justify. Since B is now the positive plate, the positively charged plate. Taking the positive direction along the circuit as that of the current, show that the differential equation in terms of UC is of this form. So in order to find the differential equation, we'll do also law of addition of voltages. But now we have UC equal to UR1 plus UR2, which means that UC is equal to R1 plus R2 times I, where we have I here equal minus dq over dt, it's discharging, so minus c duc over dt. And by substitution, we'll get uc equal R1 plus R2 minus c duc over dt, and then بنجيبها لتنجها, then we'll get R1 plus R2 c duc by dt plus uc is equal to 0. Then this is verified. The solution of the above differential equation is of the form uc equal e exponential minus t over tau 2, where tau 2 is the time constant. Show that tau 2 is equal to R1 plus R2c. بما it's a solution, this means it's verified differential equation. So طلعت معنا differential equation is سمة, okay, or is نقسمة. طلعت معنا of the form uc plus R1 plus R2 c duc over dt equal to 0. So بنعمل substitution, بس قبل we have to find duc over dt. So duc by dt is equal. So by doing now the derivative of this part, we'll get minus e over tau 2 e minus t over tau 2. And then we substitute, so هيطلع عنا e minus t over tau 2 plus r1 plus r2 times c, and هون محل duc over dt رح نحط minus e over tau 2 e minus t over, so it's equal to 0. So بناخد common factor the exponential. We'll still have from the part 1 هيبقى 1, from the second part هيبقى r1 r2 c, and we have the minus here, it's minus, and over tau 2 equal to 0, which means that 1 R1 plus R2 times C over tau 2 is equals to 1, yani tau 2 equal R1 plus R2 times C. So this is verified. The variation of the voltage you see across the terminals of the capacitor and the tangent at the instant t equals to 0 are represented. Deduce from this figure the value of the capacitance. So قلنا بيعطينا tangent, this means بدي يطلع tau using the intersection. So he will say the intersection of the tangent to the curve at t equals to 0 and UC equals to 0, the line UC equals to 0 is at which time? So is at t equals to tau, and this is tau 2, which means that tau 2 is equal to 0.02. So tau 2 equals 0.02 second. And the question is to find the capacitance. So نحن كنا قبل حطينا the expression here. So this means that 0.02 is equal to R1 plus R2. نحن كان معنا إياهم given it's 20,000 times C, which means that C equals 0.02 over 20,000. So حيطلع معنا T equal to 10 to the power 6 farad. لازم يطلع معنا same answer since we are using the same capacitor.